stand if you have a question and wait until the microphone is with you. As the chair, I'm going to take the prerogative to try and start a discussion. And it seems to me that the presentations that we've seen today, the image of sustainability is an important aspect of the making of the iconography of the projects that have been presented today. And I'm wondering how our speakers dealt with that notion of iconography and the creation of this new image, and how conscious they were of that in the making of their architecture.
Shaun.
Well, the Bahrain World Trade Center, as mentioned before, it's a very unique site. We were very fortunate to have a site like that to work with. As mentioned, it was actually, the shape of the building was actually carved from the wind, and in fact, from a lot of wind tunnel tests, we sculpted the building through the wind and in harnessing the best energy use on the turbines themselves. What it actually achieved was a building which has become very iconic in Bahrain, and I think that with the increase of having such dynamic architecture, and it's quite interesting to have something moving on a building as well, like being the turbines, where it actually has an element of the fourth dimension as well, where people who visit and pass the building or even work within the building will be very conscious of its movement. And that also helps not only just the iconism of the building, but because it's a sustainable element, we would hope that it's going to generate far more thought about where buildings need to go in the future. The Lighthouse Tower, for example, was actually it was based on the context of the DIFC area, where the client was very, very conscious, and he said he wanted a building that fits perfectly into the DIFC precinct. And that was the first response. They also wanted a lighthouse itself, and funny enough, we said we don't design lighthouses, but what he really meant was the gate building was so small that they needed something very tall. And in creating the wind generation farm, you could say at the top of the building, it's iconic in its height. And structurally, the building, because we're using a lot of steel and we have a lot of cross bracing, we started to bring up the idea of introducing the DIFC logo as being an almost mashrabiyah on the building. So that's where that came from.
Well, our buildings will have two different relationships between the shape and the wind. In the beginning, we understood that we can probably produce energy just from the wind that in old skyscrapers has a very negative effect on the building. We can use it in a positive way, in the sense that we can use the different power between the power of the wind and the rotation of the floor to produce energy. And first calculations show that probably about 10% of the consumption of the building can be used just by the wind blowing on a rotatable floor. Then we came up with the idea of putting the horizontal turbines between the floors. So having the same number of turbines and the number of the floors. But speaking about the wind, there is no doubt, and we see it now in the wind test, the wind tunnel that we do in Canada, that the building will change its shape, not only according to the desire of the inhabitants, and will be changed just according to the mood of the chief architect of the city, but also due to the wind. If we have a storm, the computerized system will just shift the floors to the best possible position from the wind point of view. And in fact, the wind tunnel people were quite difficult in the beginning, because they said we never had to do with shape. We have to do with one shape of a building, not with endless shapes. But of course, it is another challenge within the challenge.
Mr. Chairman, if I could add something from a dome engineer's point of view. It seems to the sustainability quest, from an engineering point of view anyway, there are layers in what we have to do. There are some unsung heroes in the story, I think, and that sustainability really starts with the master developer and the city. if I look at the entire Burj project, for example, it's not just the tower, there are probably 50 or 60 buildings on that site. And that the master developer, EMA, in that particular project, in their wisdom, chose to fully support the green motion by putting in district cooling. There are 4 main district cooling plants that service the entire master plan, and the recycling of water and so on. And that's done at a dense grain kind of a heavy grain level, if you know what I mean, an engineering clunky level. It's unsung, you don't see it, but it really does form the basis of that piece of the city being sustainable. So that these wonderful projects that our architect friends are doing can be showcased, as it were, and feed off that sustainable backbone. So I think my contribution to that question would be that there are layers of sustainability, and there are lots of unsung heroes there.
Questions? Microphones here.
Thank you. Judge Minder, I have a question for Shaun Killa. You mentioned generative elevators, is that correct? Can you briefly explain what it is? Thank you.
In fact, there are not too many of examples around the world. And what we're doing in the Lighthouse Tower, we have 16 double-decker elevators. And every one of them is going to regenerate energy within its own system. So, in other words, when you take people up the building, you're using energy. When the elevators are going down, and especially with people, the motors go in reverse. And it's actually quite a simple solution, which elevator companies have been dealing with for a number of years. But because it's not specified, it's not considered. Because obviously it has a small cost implication, but people are just unaware of it. And what actually happens is that within the building, your vertical movement can reduce its energy consumption by between 30 and 40% on a building with regenerative lifts. Does that answer that?
Next question. If you could just wait for the microphone, sorry.
Hello. I imagine some of these buildings are using high-performance concrete. If that is the case, can you talk a little about the suitability of aggregate quality in the region? And obviously, one way to make buildings more sustainable from an environmental standpoint is to reduce the carbon footprint of the materials. One way to do that in concrete is using fly ash. Can you talk a little about the accessibility of that here? Sorry for the specific question.
Yeah, indeed. I think all of the projects which I showed in my short presentation, and most of the sort of 80 to 100 story buildings in the region are using very high strength concrete. When I say high strength, it's at least 80 MPa and often cracking past 100 or 110 MPa. So it's some of the highest strength concrete being produced anywhere in the world. We're very, very lucky here in the Gulf. One of the northern Emirates, Ras Al Khaimah, has a basalt sort of aggregate. Eventually, I don't know if you know much about the way concrete fails eventually, but it fails through the matrix, the goo that sticks the rocks together. And eventually you can make a goo that's so strong that you fail it through the rock. So the rock is the final limiting device. And so we can happily make concrete past 100 MPa here in Dubai. In Doha, story's fairly similar. We use limestone there, which again has got a very high strength. So yes, those materials are being made here on a regular basis, and we're very, very lucky that we've got that. And we've got access also, because of the way that the construction industry is set up in the city here, we've got access to global marketplaces for all of our materials. Everything that goes into a building can be sourced happily on a global marketplace. I think it's a 5% import duty, something like that. So that we really can shop in the big supermarket for the things we need.
I can just add to that, or add on to that. Do you have any data points on sort of percentage of the materials that are imported to the construction?
I don't have anything to hand, but I would guess that probably 80% of the cement, at a guess, will be imported. The aggregates all local. sand is local as well, there's plenty of that here. And the water is all ours as well.
Question?
The question is for Dr. Fisher. I wonder what happens to the mechanical connection in those rotating units of the stored tower?
Well, these buildings, really, I call them somehow machines for living. We have machines all over us, from cars to aircraft, so exactly the same thing. The matter of fact that we believe that these buildings, we're going to have less maintenance than in normal buildings. They noticed before, my fifth commandment for architecture is maintenance. And in these buildings, everything can be removed. It's going to be like, in a way, like the Eiffel Tower that will stand forever, because every piece can be removed and fixed. The maintenance for the rotation is very limited, because the distance that this building does in 3 years is what you do with your car in 2 weeks. So maintenance is very limited due to the rotation, and all the rest you have immediate access to the maintenance. Another reason why we believe this building would stay much longer than any normal buildings we have today. We spoke about concrete, we know about the weak aspect of concrete, or the steel within the reinforced concrete. We'll have much less maintenance in our buildings.
Perhaps one last question.
Regarding...
Second.
Hi, this question is for David Fisher. I found your presentation really interesting, and the concept of dynamic buildings to be really innovative, especially when it comes to the construction features. I did have one concern, however. A lot of the images you showed these really graceful spiraling shapes as each subsequent floor changes angles ever so slightly. But as you leave control up to the building occupants, are you worried that most of the time the building's really just going to look like a hodgepodge of shapes? And how will that look on the skyline, whether it will be viewed as an eyesore versus an iconic architecture?
Well, first of all, I would like to say it's just the beginning, I believe, of a new era. So whatever the shape will be, I really don't care so much. Just to allow other people, allow architects to start to think and find solutions, that maybe better design solution. So it's just a new way of approaching buildings. But specifically to your answer, to your question, so only the top floors will have complete villas, complete apartments, and only these guys can really rotate the floor the way they want. So in Dubai it's going to be 8, the top 8 floors are going to be rotated separately. In Moscow, much bigger number, I cannot reveal it yet, but much bigger number going to be of single floors. But the rest of the building is going to be shaped by the architect, by the city architect, by the whoever. And it allows every given time to change the shape, just computerized.
And final question.
Dr. Fisher, I had a question regarding the maintenance. Being a high-rise homeowner myself, I wondered how the individual homeowner maintenance fee, or the monthly fee that a homeowner pays, how that compares to other high-rise towers here.
Well, as I mentioned before, maintenance is going to be, it sounds strange, but less expensive than a normal building. However, we are going to offer to the tenants for the first 5 years complete guarantee. In a way, like they used to say, once when you bought a Rolls Royce, even that there was any failure, they would not send you the bill. So for 5 years, we are going to give complete guarantee, and for the following 25 years, and this is going to be done by our Bosch partner, which is quite well known. It's the largest drive system company worldwide. So we are going to give for another 25 years guarantee service for a few $100s a year. So the tenants know that whatever happened, somebody will come within 24 hours. The floor will rotate again.
I'm getting the wind up from the back. So I'd like to thank all of our speakers, and if you could join me in thanking our speakers today.